In this video, we will be talking about Microsoft SQL Server TDE being used with KeySecure. TDE stands for Transparent Data Encryption. For the purpose of this video, I just made an example of a database which has one table and one entry, and it contains some kind of fake social security number, which we will use an example of sensitive data that we are trying to prevent from data leak. So this SQL Server runs is the enterprise version, which is required to run TDE with Microsoft. So one of the questions is, why do we need to actually encrypt the data? So there's an easy way to understand that, is to actually try to take a backup file of the database. So if you are going to back up the database and just going to save it in one location so that we can go back to it later on. And once you have backed up the database, you can open the file in a notepad and you can look for actually clear text data. And we have the social security number right there. So it's not good in terms of security, because if somebody gets their hand on the backup, then they can access all the data of the database. So we're trying to prevent that. But it's not just the backup that you are trying to prevent from being leaked. It's also the live database itself. If you actually stop the database service, you can just open the MDF file of our database, which contains the live data, and open it in Notepad. And again, you can look for a keyword and you'll find the clear text values just like the backup. So we're going to encrypt all that to prevent this data from being compromised. So to enable TDE, there's a list of commands to execute. So we're going to execute them all, and then we're going to explain one by one what they do and their purpose. So let's run all of these commands. The first thing to do is to enable advanced options. Then we enable EKM, which is extensible key management. Once we've done that, we can create a cryptographic provider, which is pointing to a DLL that we install. We provide an MSI that you install on the SQL Server, and you'll see here under security the new EKM there. Once we have that, we need to create some credentials which are used to communicate with KeySecure. So you see here we have a TD user, and if you go to KeySecure, here's the administration panel, we have the same user and the same password, which I already created. And so there's a password authentication to communicate with KeySecure. There's also two-way SSL that you can configure. And then the next step is to give our user, map this user with our credentials that we just created. If you're not reusing the SA user, then you can map it to whatever user you want. Next step is to create an asymmetric key, so that's RSA to 2048 key, and you see there's two different key names here, and it's a new key creation. So if you go under master security asymmetric keys, you'll see the new key being created here. And if you go back to KeySecure and look at the keys, you'll see our SQL key here. And I use two different names. It could be the same name, but you see here it's an RSA 2048, and it's being owned by the user called TD user. If you have a SQL cluster, then you can just reuse that same key instead of creating new ones. So you use a different command for that. And you can create a keys present on the server with this SQL command here. So we are halfway done, and now we need to enable TDE on our database. So there is a second set of commands which we are going to execute. The first one is to create a credentials, again, to communicate to KeySecure and associate it to a login. So we see the login here, which is mapped to the credentials. And then we connect to our database and we create a database encryption key, which is a symmetric key, AES 256, which is being encrypted with the key in KeySecure. Then we simply turn the encryption on, and there's a query here that determines the status of the encryption. And if you run it again, it'll go from encryption in progress to encrypted. Going back to KeySecure, if you look at the logs, you'll see that that key was used to do a decrypt, right? We decrypted the AES 256 key. So now that the database is encrypted, we can actually look back at our backups and our MDF file and see that it's now encrypted and secured. So we can open the MDF file again, and if we search for the same words or the social security number, nothing can be found because it's all encrypted. So if you don't have the key, you cannot do anything with this. And if you create a backup of this database, you have now the option to encrypt it. So let's put the backup in the same folder as we did before, but this time we're going to encrypt it. So now we have this option to encrypt it and secure the key with KeySecure. So it's really important to separate the encrypted data from the key, otherwise it's really easy to decrypt whatever was encrypted. And again, you see the backup file is fully encrypted.